Hi everyone, welcome back. So today we're doing something more interesting and exciting than in the previous videos. We're going to learn about how to turn on and off a circuit that's directly powered by the digital pins, as well as a circuit that uses an external power source with a Darlington chip. So let's get started. So here I'm using a simple LED circuit for demonstration. Now we're only going to focus on the right half of the breadboard, so you can ignore the left half for now. The blue buses on the breadboard are all connected to establish a common ground. Now make sure that your circuit is grounded to the same ground reference voltage, since a lot of times common ground can be a frustrating issue to debug. Now you can use any pins on the Arduino that is labeled as ground, since they all share the same voltage. So that's 2 pins after all the digital pins, 1 pin in the power bus and another one on the top left. As you can see here, LED has 2 leads. The shorter one is the cathode and that goes to the negative or ground, and the longer one is the anode and that goes to power. And if you take a look at the semiconductor inside the bulb, the smaller one is anode and the larger one is cathode. Also be sure that you connect current limit resistor to the circuits. Since the output voltage for a digital pin is 5 volt and an LED typically takes about 3 volt, a resistor is necessary to prevent any damage to the LED. So here we'll say that we want the voltage drop across the LED to be labeled as VLED, and that's 3 volt. And the voltage for the source is the V source, and that's equal to 5 volt. So the resistance for the resistor is V source minus VLED and divided by the desired current, I desired. And we say that we want a 20 milliamp across the circuit, which is equal to 0.02 amps. And plug everything back into the equation that we have. The calculated resistance is turned out to be 100 ohms. And since I don't have a 100 ohm resistor, I'll just be using a 220 ohm resistor. Now we're going to put the circuits together. Connect the resistor we just picked to any digital pins you like. You can use either the PWM pins located on top of the Arduino board, as well as digital pins on the right hand side of the board. And then connect the anode of the LED to another end of the resistor. And lastly, connect the cathode to the ground. And since we have already established a common ground across the entire blue bus, you can connect to any holes in the blue bus that you like. Now let's do some coding to control the light. Open Arduino IDE and then make sure the board type and the port options are all configured correctly. So the first thing I want to do is to set the digital pins to output mode. Here we say the pin mode, parenthesis, 22, all capital, output, parenthesis, semicolon, all code in Arduino is case sensitive. Now this line of code tells Arduino that we want to set pin 22 to be able to output some voltage. And then in the void loop, type the things that we want the Arduino to do repeatedly. Notice that the setup block only runs once to let you configure the Arduino, and then the loop block will repeat the code in it again and again and again. So in this loop block we say digital write, parenthesis, 22, all capital, high, parenthesis, semicolon. Now what this does is that we want to activate pin 22 and then let it output 5 volt. And then we want the light to be on for 1 second by typing delay, parenthesis, 1000, parenthesis, semicolon. Now the number in the delay is in millisecond, and 1000 millisecond is in 1 second. And then we're going to turn off the light by typing digital write, parenthesis, 22, low, parenthesis, semicolon. And then we want the light to be in the off state for 1 second by repeating the line above. Now hit the button upload the code to your Arduino and then save the code to a place that you can easily find next time, and then give it a good name. Now when the IDE says done uploading, this means that the code has already been uploaded successfully to the Arduino and you can watch your LED flash. So a digital pin can output enough voltage to power a single LED, but when we have any circuits that requires more than 5 volt or a relatively large amount of current, we need to use a Darlington chip. Well, it is basically a lot of switches tied together. Instead of using a flip or button, it uses a bunch of transistors. It takes a 5 volt or sometimes 3 volt digital signal for the on and off action. So here is a ULN28038 chip. So on the left side of the notch, those 8 pins are for the reading of digital signals, and the bottom one goes to ground. On the right side of the notch is where you want to plug the ground pins for your electronics, and the bottom one goes to power that you are powering your electronic with, and not the power for your Arduino. And we say 9 volt for example. So here we say the first right pin will connect to our electronics, and so the corresponding left pin will be the switch and connect to the pins on the Arduino. The bottom right pin will go to 9 volt and the bottom left pin will go to ground. Now if the electronics is an LED, the negative will go to our Darlington chip. So let's move the circuit that we just drew to the breadboard. So here's our Darlington chip. You may not see the notch very well on the camera, but it is facing that way. So here we're going to connect our signal pin to the 5th pin of the Darlington chip, and we're still using the same digital pin 22 in the previous example. And here the last pin goes to ground and the opposite pin goes to power. And then the 5th pin on the opposite side connects to the cathode of a bunch of LEDs that are connected in series. Now this series together requires roughly 9 volt. So if we supply the power bus on top of the breadboard with 5 volt, which is the same as you will get by using a digital pin, those LED will not respond since the voltage is too low. And here if we take a 9 volt battery and plug the negative to the ground bus and connect the positive to the power bus, and you can see that those LEDs start to blink. So that's all for today's video. Hope you learned something useful, and remember to give it a thumbs up. And so next time we'll be controlling an LED through a button, and see you guys next time.